Hello class, today we are going to discuss this chapter 2 of Introduction to Data Mining by Panning Tan, and this is entitled Data. The topics that we will be discussing are as follows. First, attributes and objects. Second, the types of data. Third, data quality. Fourth, similarity and distance. And fifth, the data pre-processing. But before that, let us discuss or define first what is data. Data are things known or assumed as facts, making the basis of reasoning or calculation. In the context of databases, data refers to all the single items that are stored in a database, either individually or as a set. In this topic, we will be discussing some data-related issues important for successful data mining. And we will discuss 4 of these issues. First is the type of data. Second, the quality of the data. Third is the data pre-processing. These are the pre-processing steps to make the data more suitable for data mining. And the last is the measures of similarity and dissimilarity, which are the methods or processes of analyzing data in terms of its relationships. The type of data. Data sets, we all know, differ in a number of ways. For example, the attributes used to describe data objects can be of different types. It may be qualitative and quantitative. We will be discussing attributes later on. Data sets may have special characteristics. Some may have data sets containing time series or objects with explicit relationships to one another. The type of data is important issue for successful data mining because it may determine which tools and techniques can be used to analyze the data. Pag alam natin kung ano yung type ng data, madali na nating malalaman kung anong dapat nating gamitin for a successful data mining. Furthermore, new research in data mining is often driven by the need to accommodate new application areas and their new types of data. Next is the quality of the data. Data is often far from perfect. While most data mining techniques can tolerate some level of imperfection in the data, a focus on understanding and improving data quality typically improves the quality of the resulting analysis. These issues may include the presence of noise and outliers, missing, inconsistent, or duplicate data, or data that is biased or unrepresentative of the phenomenon or population that the data is supposed to describe. So that's the second data-related issue that we will be discussing later on. Next is the data pre-processing. Often, the raw data must be processed in order to make it suitable for analysis. While one objective may be to improve data quality, other goals focus on modifying the data so that it better fits a special data mining technique or tool. Examples natin for this, we have length transformed into an attribute with discrete categories like short, medium, or long in order to apply a particular technique. Second example, the number of attributes in a data set is often reduced because many techniques are more effective when the data has a relatively small number of attributes. May ganon. May mga techniques na kailangan maliit lang ang number of attributes. Meron namang techniques na kaya niya yung maramihan. Pero kapag kailangan niya or ang magagamit mo lang siya para sa maliliit na number of attributes, kaya naman nating i-transform yung attribute na yun or yung value ng attribute i-transform natin para paliliitin natin yung mga choices. Katulad nga ng example na length, instead na exact length or numeric length, ilalagyan na lang natin ng categories like short, medium, or long. Measures of similarity and dissimilarity. One approach to data analysis, which involves finding relationships among the data objects and then perform the remaining analysis using these relationships rather than the data objectives themselves. An example of this is we can compute the similarity or distance between pairs of objects and then perform the analysis clustering, classification, or anomaly detection based on these similarities or distances. There are many such similarity or distance measures, and the proper choice depends on the type of data in the particular application. This will be the last topic that we will be discussing later on. Now let's go to the first issue. Let's discuss the types of data. What is a data set? Isa to sa mga palagi natin gagamitin na terminology. Pag sinabing data set, it is a collection of data objects and their attributes. A data object is also called a record, a point, a vector, a pattern, event, case, sample, observation, or entity. It is described by a collection of attributes. Kung matatandaan ninyo sa databases natin dati, pinapaname ko kayo ng mga entities and then inaalam ninyo kung ano yung mga attributes ng entities na yon. Now, those entities o kaya isang record sa table ninyo is one data object. What is an attribute? An attribute is a property or characteristics of an object. It can also be called as variable, a field, a characteristic, a dimension, or a feature. So, example niyan, sabi nga natin characteristic. So, pwedeng mass, shape, temperature, etc. Now, let us consider this example. Table 2.1. This is a sample data set containing student information. Often, a data set is a file in which the objects or records or rows in the file and each field or column corresponds to an attribute. Now, the year, the grade point average, or the GPA, the student ID, these are all the fields or the column of the table, which serves as the attribute, whereas all the rows are the objects or records. What's an attribute? An attribute is a property or characteristic of an object that may vary either from one object to another or from one time to another. Of course, examples are eye color and temperature. Sa eye color, we only have small number of possible values. Pwedeng meron lang tayong mga, siguro hindi lalampas ng 10 different eye colors. We have black, we have blue, green, brown, dark brown, light brown, blue-green, etc. But it's just a small number of possible values. Whereas temperature is a potentially unlimited number of values. Pwedeng from 0 to 1,000 of degrees ang temperature. So, it's unlimited actually. Until now, hindi natin alam kung ano ang highest temperature na possible. But we have, of course, yung tinatawag nating absolute temperature sa inyong physics. So, matataas na yung temperature na yon. Now, what are measurements and measurement scale? A measurement scale is a rule or a function that associates a numerical or symbolical value with an attribute of an object. Example nito yung Fahrenheit, grams, meter, kilometer, ano pa ba? Sa time, yung seconds, hours, yon. Those are measurement scales. Yung measurement naman is the process of applying a measurement scale to associate a value with an attribute of an object. Now, say for example, ang ating attribute is weight. At ang ating measurement scale is in kilograms. Now, you measure that and your measurement, say, ang reading mo is 5 kilograms. So, that is your measurement, 5 kilograms for the weight. Example naman sa temperature, if your attribute is temperature, at ang ginagamit mong measurement scale is in Celsius. So, kung ang reading mo, say for example, boiling point of water is 100 degrees, so yun yung iyong measurement. That's 100 degrees Celsius. Yun yung temperature measurement mo. Okay po? Attribute values. Ano po iyon? Attribute values are numbers or symbols assigned to an attribute for a particular object. What is the distinction between attributes and attribute values? Sabi nga, pag sinabing attributes, yung weight. Okay? Yung attribute values, yung 5 kilograms. Okay po? Yung 5. Okay? Same attribute can be mapped to different attribute values. Example, height can be measured either in feet or in meters. Iisang attribute siya, pero pwedeng iba-ibang attribute values. Pwedeng in feet, pwedeng in meters. So, halimbawa, kung 3 feet siya, 1 meter. So, magkaiba, di ba? Magkaiba yung kanilang attribute values, pero pareho lang yung attribute na pinatutungkulan. Different attributes can be mapped to the same set of values. Say, for example, yung attribute values natin for employee ID, tsaka employee age. They may be both integers, but they are of different attributes. Diba? But pareho silang integers. Pero hindi mo sasabihin parehong attribute yun. Okay po? Magkaiba sila, pero iisa lang yung set of values na ginagamit sa kanila. Ito yung sa counting numbers natin. Properties of attributes can sometimes be different than the properties of the values used to represent the attribute. The way you measure an attribute may not match the attribute's properties. Example po nito, halimbawa length or distance. Sabihin, gaano po kalayo yung sa baryo? Gaano po kalayo papunta sa tawag dito? Sa falls. Pupunta po kami sa falls mula rito sa paanan ng bundok. Gaano po kalayo ang aming lalakbayin papunta sa falls? Anong attribute? Distance, length. Pero ano sasagot sa'yo ng mga tao doon sa probinsya pag nagtatanong ka? Naku, iho, mga 1 oras na lakarin yan. Okay, mga 1.5 oras na lakarin. Pero pag nakasakay ka sa jeep, mga pwede na yung 40 minutes lang. So, ano yon? Magkaiba, di ba? Ang attribute mo is length or distance. Pero, ang binigay sa iyo na value is in time. Unit of time. Hours. 1.5 hours. 1.5 oras. So, the way you measure an attribute may not match the attribute's properties. Pero nagkakaintindihan pa rin pag minsan kung ano-ano lang. Pero hindi tama yon. Kasi hindi mo makukuha yung mismong property ng attribute. Okay po, dapat mo pa rin i-convert sa totoo niyang attribute. Types of attribute. The type of an attribute should tell us what properties of the attribute are reflected in the values used to measure it. It allows us to avoid foolish actions to be done on the data. Kapag alam mo yung type of attribute, medyo mag-guide ka sa mga actions o kaya operations na dapat mong gawin. These are commonly referred to as the type of measurement scale. Kasi halimbawa, yung example natin kanina, ayan na pala, employee age and ID number. Pareho silang integer. Anong difference ng dalawa? Yung employee age, integers din siya pero with limit. Wala naman sigurong empleyado na bababa sa 5 years old at wala ring empleyado na mas matanda pa sa 100 years old. So, may limit tayo. Pero pag ID number, Pwede hanggang libo-libo or 10,000 kung multinational yung company ninyo. So, distinct, unequal, limitless integer pag ID number. Whereas pag age, may limit, pero ito yung makapagre-represent ng properties talaga ng attribute ng tao. Tao kasi yung may attribute natin, empleyado. So, meron talaga siyang age. Para saan ba lang ba yung ID number natin? Para lang ma-distinguish natin kung sino yung specific tao na yon. And dapat wala siyang kapareho. Kasi gagamitin lang natin siya as primary key or as distinction dun sa empleyado. Okay po? So, kapag ka age, pwede nating alamin, halimbawa sa kumpanya natin, sa isang, sa isang kumpanya natin, alamin natin yung average age ng mga empleyado. Pwede yon. Pero ID number, pwede mo bang kunin yung average ng ID number? Para saan? Wala, 'di ba? Pwede mo nga pagpalit-palitin ng ID number yan eh. Kung gusto mo lang. Pero ibig ko sabihin, walang average ID number. Merong average age. So, yan yung sinasabi dito na it allows us to avoid foolish actions to be done on the data. Pag alam mo yung type of an attribute. So, if you know what an ID number is and you know what age is, you'll know. So, hindi mo kukunin yung average ng ID number because you know what type of an attribute that is. What are the different types of attributes? There are different types of attributes, namely nominal, ordinal, interval, ratio. May mga examples tayo dyan. So, pag nominal, tingnan nyo po, ID number, eye color, zip codes. Pagka ordinal, rankings, grades, height. Pero, tinatransform natin sa yung height, hindi mismong height. Gagawin mo siyang tall, medium, short, very short, etc. Pagka rankings, merong good, very good, o kaya yung 1 to 10. Scale mo from 1 to 10. O kaya yun ngayon sa grades, yung outstanding, very good, good, needs improvement, yung mga ganon, hindi ba? Interval. Examples nito yung mga calendar dates. Basta yung may mga interval. Pag sa calendar dates per day is, ang interval nyo is 24 hours. Temperatures in Celsius or Fahrenheit, ang interval nito yung degrees. 1 degree each sa temperature. 1 temperature degree or 1 Celsius degree or 1 Fahrenheit degree. So, isang kudlet dun sa thermometer. Ratio. Examples nito yung temperature in Kelvin. Ito, medyo siguro hindi nyo masyado maintindihan ba't yung absolute temperature ito. Delta T to, kumbaga kung sa thermodynamics ninyo or sa physics, kung naalala nyo yung MC delta T. Okay, ito po ay delta T yung temperature in Kelvin. Absolute temperature siya. Length, counts, elapsed time, or time to run a race. That's ratio. The type of an attribute depends on which of the following properties of numbers or operations it possesses. Ito yung mga different properties of numbers. Meron tayong distinctness, order, meaningful differences, meaningful ratios. Ano yung distinctness? Distinctness, ang mga operations lang yan is either equal or unequal. So, you just compare if it is equal or if it is unequal. So, example niya na laging ginagamitan nito yung mga ID number or yung mga primary keys. Dapat laging unequal. Wala dapat kapareho. Order, alin ang mas mauuna? So, in order, dapat i-compare mo which is higher, which is lower. Kasi kung in ascending order ang gusto mo, it should be yung less than muna bago yung greater than. Pero kung gusto mo in descending order, yung greater than muna bago yung less than. So, you have to compare first which is lesser in value or which is greater in value to be able to use order. Meaningful differences, sorry, yun yung operation for order property. Meaningful differences, ang mga operations lang na involved dito is addition, subtraction. So, differences, is it greater than or equal din naman? O, pag dinagdagan ng, dadagdagan mo lang ng ganito o kaya babawasan mo ng ganito, yun yung values niya. Ang properties is meaningful differences, ang operations involved plus, minus. Meaningful ratios, ang operations involved is multiplication and division. Now, yung mga types of attribute natin, ano-ano yung mga properties of number or properties of numbers na pinopossess niya or aling ka-partner niya o kung ano yung ginagamit sa kanya. Sa nominal attribute, ang ginagamit lang distinctness or yan lang yung kanyang pinopossess or meron siya distinctness. Sa ordinal attribute, may distinctness and order. Sa interval attribute, distinctness, order, and meaningful differences. Sa ratio attribute, lahat ng 4 properties of operations pwede sa kanya. Now, take note, each attribute type possesses all of the properties and operations of the attribute types above it. Tulad nito, yung sa ratio, all 4 properties, kasama sa kanya yung lahat ng properties sa interval attribute. Sa interval attribute naman, lahat ng properties of number na nasa ordinal attribute nasa kanya, plus 1. Sa ordinal naman, meron na siyang order, meron pa siya nung kung ano yung meron doon sa nasa taas niya. Yun yung ibig pong sabihin nitong note natin. Now, lahat nung diniscuss natin, nandito ang summary sa table 2.2, different attribute types. Ito po yung attribute types, ito po yung description, mga example, tsaka yung mga operations involved. Karamihan ng operations dito ay diniscuss ninyo sa inyong itong subject na to. Kay Ma'am Marquez, yung statistics and probability. Yan, kung meron kayo. Now, ito katulad nitong chi-square test, Pearson's correlation, F-test, T-test, etc. Okay po. Now, may makikita kayo dito sa gilid. Yung nominal and ordinal, they are categorical or qualitative. Dito naman, interval and ratio, numeric and quantitative. Ano ba yan? Yung dalawampung yun ay ang 2 general classification of attributes. Yung isa nga yung categorical or qualitative attributes. This means lack most of the properties of numbers. So, di numerical. More on quality rather than numbers. Even if represented by numbers, they are treated more like symbols. Tulad nga ng mga primary keys natin. Kung matatandaan ninyo, yung mga ID number or antag dito, employee ID o kaya student number natin na nilalagay sa databases natin, ang data type na nilalagay natin, normally hindi number. Ang nilalagay natin text. It is not considered as number normally. Now, under ng categorical and qualitative, yung nominal and ordinal attributes. Okay po. Next classification yung numeric or numerical or quantitative attributes. These are represented by numbers and have most of the properties of numbers. Interval and ratio are collectively referred to as numeric or quantitative attributes. So, yung dalawa doon as we have seen in table 2.2. Ito po. Yung interval and ratio are under numeric or are classified as numeric or quantitative attributes. Okay? So, lahat dito, numbers. Katulad ng length, ng weight, ng height. These are quantitative or numeric. Now, what is permissible transformations? The changes that preserves the attribute's meaning is called a permissible transformation. Take note, the statistical operations that make sense for a particular type of attribute are those that will yield the same results when the attribute is transformed using a transformation that preserves the attribute's meaning. So whether you change the attribute, okay lang yun, o itatransform mo siya into another form, pero hindi nawawala yung meaning niya, yun yung tinatawag nating permissible transformations. At sabi niya nga, pwede ito sa mga statistical operations. Meron kasi mga statistical operations na hindi po pwede yung halimbawa, kilograms sa weight. Hindi po pwede. So, gawin nating English. Gawin nating in pounds. So, na-transform natin siya into pounds, pero acceptable siya. Yung pa rin yun. Hindi na alter yung meaning ng attribute na yun. Still, it's weight. Now, table 2.3 is shows the transformations that define the attribute levels. Okay? So, comments. Halimbawa sa nominal, ang comments, if all employee ID numbers were reassigned, would it make any difference? Sabi, no. Magkakaroon ng difference kung nasanay ka na, pero yung assignment, reassignment ng pagpapalit-palitin mo lang yung mga ID number nila, okay lang yon. Kaya lang, ano lang yan ano-ano lang natin, kunwari lang. Pero sa totoo, syempre, hindi mo na pagpapalit-palitan yung mga, hindi mo na i-reassign. Kaya lang, ibig sabihin, wala namang effect kahit kanino mo ibigay yung ID number. Huwag lang magdodoble. Ordinal. Okay, an order preserving change of values. New value equals a function of the old value, where f is a monotonic function. Ang comments, an attribute encompassing the notion of good, better, best can be represented equally well by the values 1, 2, 3 or by 0.5, 1, 1.0, etc. So that's yung transformation, yung pwede daw yung ganyan. So, pag sinabing good, better, best, pwede din yung 1, 2, or 3. Diba, pag nag-grade tayo sa evaluation, sabi mo, very good is 5. Ang tawag dito, needs improvement is 1. Okay? So, pwede yon. Pwede mong i-alter or pwede mong i-change or i-transform yung values mo, yung attributes, but still, yung values or yung meaning ng attribute does not change. Okay, for interval, new value equals A times the old value plus B. So, where A and B are constants. Thus, the Fahrenheit and Celsius temperature scales differ in terms of where their zero value is and the size of a unit degree. Ibig sabihin, yung laki kasi, pag makita mo yung laki ng distances ng degrees sa Celsius and Fahrenheit, mas malaki yung sa Celsius. Kaya yung Fahrenheit, pag nagbasa ka, mas malaking value. Okay, now, if you will transform Celsius to Fahrenheit or vice versa, ito yung format na gagamitin mo, di ba? Say, for example, may formula ng temperature in degrees Fahrenheit is equal to, ano ba yun? 2/3, 3/2 of temperature in degrees Celsius plus 32. Di ba parang ganon? Hindi ko na maalala yung formula. Pero parang ganon. May i-add ka. Kung temperature in degrees Celsius naman, temperature 2 times the temperature of degrees Fahrenheit minus 32 all over 3. Okay? Or divide by 3. Yung sagot nung yun, divide by 3. So, parang ganito yung formula niya. Okay po. Ratio. New value equals A times the old value. So, walang addition, walang subtraction. It's either multiplication or division. Say length. Sabi comments, length can be measured in meters or feet. Kasi ano siya, multiple, say 3 feet equals 1 meter. So, pwede mong length in meters equals 3 times length in feet. Sorry, hindi ko na sinulat dito, pero more or less, alam nyo naman yung value ng pagko-convert from feet to meters. Parang ganun lang. Pwede na sa temperature in Kelvin, between Kelvin and Rankine, 1 Kelvin is equal to the temperature in Rankine divided by 1.8. Kung babaliktarin mo naman, temperature in Rankine is equal to 1.8 times temperature in Kelvin. So, ito na yon. Halimbawa, Rankine equals 1.8 times Kelvin. Yun lang yun. So, that's ratio. Describing attributes by the number of values. We have discrete attribute. Discrete attribute has only a finite or countably infinite set of values. Countably infinite. So, ibig sabihin na ano pa rin, nakakount mo pa rin. It can be categorical, like zip codes, counts, or the set of words in a collection of documents, or often represented as integer variables. So, it can be categorical. It often represented as integer variables. But take note, binary attributes are a special case of discrete attributes that assumes only two values. Pwedeng true and false, yes or no, male or female, 0 and 1. Ang tawag dun sa mga ganon, yung special case of discrete attributes that assumes only two values, we call that binary attributes. Now, binary attributes are often represented as Boolean variables or as integer variables, 0 or 1. Basta pag may binary, dalawa lang. Binary attributes meaning dalawang attributes lang. Okay po? Two values lang. This is under the discrete attribute kasi countable siya. Dalawa. So, that's countable. Continuous attribute has real numbers as attribute values. So, when you say real numbers, lahat ng klase ng numbers kasama dyan. Yun doon sa una natin, discrete attributes, these are integers only, whole numbers, 1, 2, 3, 4, 5, counting numbers lang. Finite. Pero pag sinabing real numbers, kasama lahat dyan, may mga decimals pa kung gusto mo, fractional parts, etc. That's real numbers. So, a continuous attribute has real numbers, has attribute values. Example niyan, temperature. Diba ang temperature is 36.5, 36.4. Yung height, ganun din. Now, depending on the height that we are discussing, pwedeng height na maliit or height na mataas. Ito namang weight, ganun din. Merong napakabigat, merong hindi. So, walang limit, kumbaga, pag continuous attribute. But of course, lahat naman dito sa, lahat ng, mini-measure, may limit yan. Pero yung continuous attribute, pwede mong gamitin ang unlimited number of values. Continuous attributes typically represented as floating point variables. Ano nga ba yon? Floating point, kayo diba sa programming nyo? Pag floating point, may decimal values or may fractional part, may decimal part na numbers. Yun nga sabi ko kanina, 36.2, 37.5, ganyan. Halimbawa, yung weight mo is 4.52 kilograms. Ganon. Practically, real values can only be measured and represented using a finite number of digits, of course. Hindi na natin siya maano kung talagang unlimited siya. Katulad nung, antag doon, yung ganon. Yan, hindi na. Hindi na talaga natin madedata mine. May hirapan tayo. Pero, ibig lang sabihin ng continuous attribute, wala kang limit sa gagamitin mo. As much as gusto mong gamitin yon. Pero, yung values na yon, or as much as yun yung value, Kaya lang, alam naman natin, everything has limit. May finite number lang. Hindi naman natin talaga, wala naman talagang infinite. Okay po? Asymmetric attribute, ano ito? An asymmetric attribute is one where only presence is regarded as important. Ano yung ano ibig sabihin na only presence is regarded as important? Ang kinukuha lang nila yung mga non-zero attribute values. Example nito, kung hanapin mo lahat ng words na yung isang specific word sa isang document. Halimbawa, lahat ng word na the. Hanapin mo kung ilan yon. Yun lang yung hanapin mo. So, bilangin mo yun, hindi pwede yung non-zero. Hindi pwede yung mga zero attribute values. Okay? Mga items present in customer transactions. Isang example din pala nito, halimbawa, yung example natin sa book, yung students na enrolled sa specific course. Halimbawa, lahat ng UDM students enrolled in IT. So, lahat lang na kukunin mo, kung meron ka list sa database mo, ang kukunin mo lang yung mga enrolled sa IT. Hindi mo na kukunin yung ang magiging attributes nila 0. Kung i-convert mo kasi, kung enrolled sila sa IT, meron silang 1. Pagka hindi sila enrolled sa IT, 0. So, lahat lang ng may 1, yun lang ang kukunin mong value. Okay po? So, that's asymmetric attribute. It's an asymmetric binary attributes. These are binary attributes where only non-zero values are important. Binary ulit. So, dalawahan lang. It is particularly important for association, analysis. Ito nga yung sinasabi ko kanina, it's either 0 or 1 lang. Yung example ko sa enrolled sa IT. So, it's either 0 or 1 lang. Dito kasi sa words present in documents, hindi lang 0, hindi lang 1 yan. Marami. It is also possible to have discrete or continuous asymmetric features. For instance, if the number of credits associated with each course is recorded, then the resulting dataset will consist of asymmetric, discrete, or continuous attributes. Kung marami na yung sa listahan mo. So, that's a continuous asymmetric attribute. And now for the data sets. Let us now discuss the 3 general characteristics of data sets that have a significant impact on the data mining techniques, namely the dimensionality, sparsity, and resolution. Let's discuss each. Let's start with dimensionality. Dimensionality refers to the number of attributes that the objects in the dataset has. Data with a small number of dimensions is qualitatively different than moderate or high-dimensional data. Pag sinabing dimensions, it's more of, or dimensionality, kung maraming attributes, we call it a low-dimensional dataset. Pero kapag ka marami, katulad ng sa mga banks o kaya sa National Statistics Office or Philippine Statistics Authority, napakarami ng mga attributes per data object na ating kinukuha nung agency na yon. So, we call it a high-dimensional data. Ibang-iba po ang pagde-data mine using small number of dimensions versus high-dimensional data. Meron tayong mga tinatawag na curse of dimensionality. Ano ibig sabihin nun? It refers to the difficulties associated with analyzing high-dimensional data. Mas mahirap po kasing i-analyze kapag napakaraming attributes ang isang data or sa isang data set. Ngayon, paano natin malalabanan yung curse of dimensionality? We have something that we call dimensionality reduction. Ano yon? That is the pre-processing operation devised to combat the curse of dimensionality. I-discuss po natin to under pre-processing. Ano ba yung dimensionality reduction? Pero from the name itself, alam ko meron na kayong idea. Ano naman po yung sparsity? For some data sets, such as those with asymmetric features, most attributes of an object have values of 0. In many cases, fewer than 1% of the entries are non-zero. So in practical terms, sparsity is an advantage because usually only the non-zero values need to be stored and manipulated. This results in significant savings with respect to computation time and storage. Furthermore, some data mining algorithms work well only for sparse data. Sabi niyo, ano ba yung sparse data? Yung sparsity, from definition, it's a condition of containing few relative to its size. So, the fewer, the better. The easier to analyze. Ayan po. Resolution. Ano na may resolution? Sabi sa dictionary, the ability to show an image clearly and with a lot of detail. This is specifically related to devices that captures images. Yung definition na to. So, it's the ability to show an image clearly and with a lot of detail. That's resolution. Normally, ini-express natin ang resolution in terms of pixels sa course natin. Now, it is also the ability of the measurement system to detect and faithfully indicate small changes in the characteristic of the measurement result. So, sa topic natin, the properties of the data are different at different resolutions. Ibang resolution, iba yung nagiging property ng data. Patterns in the data also depend on the level of resolution. If the resolution is too fine, a pattern may not be visible or may be buried in noise. If the resolution is too coarse, the pattern may disappear. Halimbawa, pag kinuhanan mo pag mas malapit ka, mas detalyado, mas malaki ang nakikita mo, pero yun lang part na yun. Bali parang specific part lang ang makikita mo. That's resolution. Yun lang yung malinaw mo makikita. Kaya lang ang problema, hindi mo nakikita ng buo, so you do not see the pattern. Pag nilayo mo naman, yung kuha mo, you would see naman the whole figure or the whole data kung ano man yon. Makikita mo ng buong buo, pero kaya lang may mga parts na hindi na niya kasama na nakikita mo pa rin. Yung pag sinasabi nating bird's eye view, pag mas malayo, parang mas makinis. Pero marami namang noise. Ano yung noise? Yung nasa paligid ng mga hindi na kailangan na data. Okay? Pag pinalaki mo or pag in-enlarge mo, lalo mo nang hindi mo naman, parang pangit naman yung image. Kaya nga nagpipixelize, sabi nga. So, in terms naman of, say, ibang klase ng data, sabi natin hindi image, sabi natin halimbawa yung mga data tungkol sa behavior ng mga volcanoes natin. Kapag kinuha mo siya, yung behavior niya, every second o kaya every minute kinukuha mo yung data, parang hindi mo masyadong makita yung pattern. Kung kukunin mo naman siya every month, every month, parang ang layo din, hindi mo rin agad makikita yung pattern. Parang mas maganda yung tama lang na resolution at maganda rin kung lahat ng data mo ay pare-pareho or halos magkakalapit ng resolution. Huwag magkakalayo kasi parang hindi magiging maganda yung pag-a-analyze or hindi magiging madali yung pag-a-analyze kung iba-iba yung resolution ng mga data mo. So, tama lang siguro kung every hour ang pagbabantay mo doon sa behavior ng volcano. At least makikita mo kung ano na talaga yung behavior. Mas madali siyang makita. Andun din yung tawag dito, yung konti lang yung nakikita mo. Mas konti, dimensionality reduction, parang ganun. Mas konti yung data mo, mas makikita mo yung pattern. Okay po. So, sa resolution, yun namang lapit or layo nung pagkuha mo ng data. Pwedeng image lang o kaya yung data, yung period ng pagkuha ng data. Pwedeng sa period, pwedeng sa mismong pagkuha sa image. Pag period, yung by time frame. Okay po? That's resolution. Now, let's go to the types of data sets. There are many types of data sets, and as the field of data mining develops and matures, a greater variety of data sets become available for analysis. In our topic, we will describe some of the most common types of data sets. And ang i-discuss natin is three groups or three common groups of data sets. We have the record data, the graph-based data, and the ordered data. Let's start with the record data. Record data is a data set that consists of a collection of records, each of which consists of a fixed set of attributes, usually stored either in flat files or in relational databases. There are different types of record data, which includes transaction data, data matrix, and the sparse data matrix. Let's discuss the transaction data. A special type of data where each transaction involves a set of items. For example, consider a grocery store. The set of products purchased by a customer during one shopping trip constitute a transaction, while the individual products that were purchased are the items. Please see the illustration here. Transaction data, also called market basket data, because the items in each record are the products in a person's market basket. So please take note, pag transaction data, it means one transaction equals one record. Data matrix, a type of record data which consists of mostly numeric attributes. That's why standard matrix operation can be applied to transform and manipulate the data. The standard data format for most statistical data. It's also called a pattern matrix. Here's an example of a data object which consists of data matrix. In the data matrix, please take note it is mostly composed of numeric data. Sparse data matrix, a special case of a data matrix in which the attributes are of the same type and are asymmetric, meaning only non-zero values are important. Each term is a component attribute of the vector. The value of each component is the number of times the corresponding term occurs in the source, like in a document. This representation of a collection of documents is often called a document term matrix. Now, if you may notice here, say for document 1, we have team 3, coach 0, play 5, etc. Kung ilan lang, bibilangin mo, tapos yun yung ilalagay mo, yun yung sparse data matrix. This is an example of a sparse data matrix. Graph-based data. A graph can sometimes be a convenient and powerful representation of data. The relationships among objects frequently convey important information. In such cases, the data is often represented as a graph. There are two specific cases which we can consider. First is the graph captures relationships among data objects. And second, the data objects themselves are represented as graphs. Okay? With With relationship among objects, we may have this example, which is a web page. The relationships among objects frequently convey important information. In such cases, the data is often represented as a graph. The data objects are mapped to nodes of the graph, while the relationships among objects are captured by the links between objects and link properties. The second type, which is the data with objects that are graphs. Doon sa kabila, yun sa isa yung kanina, data with relationship among objects. So, objects ang may relationship, object to object. In here, object mismo yung graph. Mismong yung object ang graph. Okay? If objects have structure that contains sub-objects that have relationships, then such objects are frequently represented as graphs. Example of this is the structure of chemical compounds, which can be represented by a graph where the nodes are atoms and the links between nodes are chemical bonds, just like the benzene molecule or the C6H6. The third type, which is the ordered data. For some types of data, the attributes of relationships that involve order in time or space. So when you say ordered data, it has a certain order. It may be according to time or according to specific order, like in some cases alphabetical, ascending, descending, or with a specific structure that you have to follow. Different types of ordered data includes sequential data, sequence data, time series data, and spatial data. Let's start with the sequential data. From the term itself, sequential data can be thought of as an extension of record data, where each record has a time associated with it. It's also record data, but with a time associated with it. Also referred to as temporal data, because it refers to data that represents a state in time. Temporal means that which is related with time. So, example, say consider a retail transaction data set that also stores the time at which the transaction took place. This time information makes it possible to find patterns such as candy sales peak before Halloween. Or, say, if you have patterns of transactions that every Christmas many are buying, whereas many are buying toys and candies, but during February's, pinakamabenta is flowers and candies and teddy bears. So may mga ganon. Makikita mo yon according sa pattern ng sales or retail transactions. Now, second example, yung purchase history of a customer with the listing of items purchased at different times, which may show purchase patterns of customers. A time can also be associated with each attribute. Consider the sample below. Ito yung pinlat natin sa isang table or nilagay natin sa isang table. Pag sinabing sequential data, since temporal to, according to time, so chronological usually. So time 1, time 2, time 3, meron tayong up to time 5. Tapos, nandito din yung customer. Specific time, yung kung sinong customer at anong mga items na pinurchase niya. Ito sa table 1, ganon. Anong time, sunod-sunod ng time or chronological in order. Tapos yung customer, kung sinong customer, we have here customers 1, 2, 3. At yung items purchased nila, yung mga products na A, B, C, D, and E. Makikita nyo kung ano mga binili nila. If you will create another table wherein you will analyze somehow or you will create a specific analysis somehow at ita-table mo na, pwede nang gawin mong key attribute yung customer. So, yung key attribute natin, or the primary key natin is the customer. So, customer number 1, 2, and 3. Tapos, ipapakita mo dun yung time and items purchased. Sama, makikita mo rin kung ano yung mga buying habits ng bawat customer mo. Okay po? Next is the sequence data. What's the difference between sequence data and sequential data? Sequence data consists of a data set that is a sequence of individual entities, such as a sequence of words or letters. It is quite similar to sequential data except that there are no timestamps. Instead, there are positions in an ordered sequence. Normally, sequence data are used for biological sequence analysis. So, sikat na sikat po itong word nito na sequence data when it comes to biological sequence analysis. Biological sequence analysis compares, aligns, indexes, and analyzes biological sequences, which can be either sequences of nucleotides or of amino acids. Biosequence analysis plays a crucial role in bioinformatics and modern biology, which you may be a part of later on. So the difference between sequence and sequential data, when you say sequential data, meron tayo, sabi temporal data or with respect to time. So, kino-consider ang time element. Or us, in the sequence data, we don't. We are more concerned with the arrangement. Okay? Order or arrangement. The sample figure below shows a section of the human genetic code expressed using the four nucleotides from which all DNA is constructed, yung A, T, G, and C nucleotides. We call this, itong specific example na to, as the genomic sequence data. So you'll see here the arrangement of the DNAs. Okay, how a DNA is constructed. Next, time series data. So time series data, parang ano na rin siya, no? Parang temporal din ang data niya kasi ibig sabihin, it pertains to time or may kinalaman sa time. Time series data. So, time series data is a special type of sequential data in which each record is a time series, meaning a series of measurements taken over time. Ito not just events but measurements as well. So, this is more of measurements, more of observation. Okay? When working with temporal data, it is important to consider temporal autocorrelation. That is, if two measurements are close in time, then the values of those measurements are often very similar. Hindi nagkakalayo kung magkakalapit. Kaya kung natatandaan ninyo, yung isang diniscuss natin, yung about yung time element, yung closeness sa resolution yon na topic. Kaya lang, sa resolution, more of visual, but it can also be related with yung time element, yung period, yung closeness of the time element. Ganon din dito sa time series data. Pag sinabing temporal autocorrelation, sabi nga, if two measurements are close in time, then the values of those measurements are often very similar. Halos hindi nagkakalayo yung makukuha mong data. Kaya nga hindi mo kagad makikita yung pattern kung masyadong magkakadikit. Pero kung marami kang kukunin na data na magkakadikit, makukuha mo rin later on. Kaya lang, syempre, hindi mo na i-consider yung mga in-betweens. Kumbaga, magkukuha ka ng every period na medyo magkakalayo ng konti. Example of a time series data is financial data set, which might contain objects that are time series of the data prices of various stocks. So, yan time series data. Okay, yung sa stock market. every hour, every hour may changes in stocks. Spatial data. Spatial data are data that have a spatial component. It means that data or are connected to a place in the earth. Spatial pertains to space. Ayan po, para maintindihan po natin. So, spatial data comprise the relative geographic information about the Earth and its features. A pair of latitude and longitude coordinates defines a specific location on Earth. Spatial data are of two types according to the storing technique. We have the raster data and the vector data. Pag sinabing raster data, it is somewhat yung aerial photographs. Whereas pag vector data, it pertains to geometric locations, yung mga X and Y coordinates. So, more on drawings na isasabihin sa yung location, exact location by means of its X and Y coordinates. Okay? Some objects have spatial attributes such as positions of areas as well as other types of attributes. Here's an example of a spatial data. This is a weather data that is collected for a variety of geographical locations. So, ayan. If you may notice, this is an example of a vector data. Kasi merong mga longitude, latitude, and longitude, which is the X and Y coordinates. Although, pwede ding raster kung picture yan na kinunan, pwede din. Okay? And that ends our lesson 1, which is all about types of data. Lesson 2 is about the quality of data. Thank you for listening, and let's proceed with or to lesson 2. Thank you.